Hey guys, so I'm going to start off with the question, why is it so slow? Because that's the question we most of the time ask ourselves, and we see something and we try to figure out what it is. And this question is really the reason for this N+1 story, because with an N+1, as most of you already tackled it, it's very hard to understand why it's slow, right? This is very hard to see why it's slow. So this is a story about that. I'm going to go through phases of how I got there and all of this, but I'm going to show you a few different solutions than what you would normally get. Okay. First thing, I have a slide just about this being a niche problem, because some people would tell me this is niche, doesn't happen anymore, there's things like that. But when I was trying to do this slide, I noticed going on LinkedIn just last week, 4 days ago, someone posted the same issue where they spent 11 hours trying to debug this problem, where their dashboard was taking 45 seconds to load. Users were starting to create support tickets, complaining, and you'll notice some key words or key important hints. Started having 13,000 queries to page that one load onto the database. Eventually, when they figured out it was an N+1, they fixed it. The load time went from 45 seconds to under 1 second. So this is very interesting, and it happens quite often. So again, looking more, there was again some other people, 600 queries around, turned into 5 queries. It became very fast, instant loading page, another culprit, so forth, so on. And what's more interesting, all of these have different type of languages they're using. The Django, Laravel, PHP. In my case, it was with Java, with my current company. And any language could happen until you have an ORM, or you have someone, a middleware that's doing the things for you, doing the queries to the database for you. So this is about that. Now, who am I? I'm Reza. Nice to meet you guys. I'm a software developer. I'm a thinker. I like to play around with stuff. And I'm soon to be dad. In March, I'll have my daughter. So yeah, thank you. No need for clap, but thank you very much. So I used to be a teacher for almost 10 years. And afterwards, I kind of got bored because I wanted some challenges. I came back to the industry. So you should know me as I like challenges. I like finding these challenges and solving them, and I find this very fun. And lastly, I'm being sponsored by my company. They allowed me to come here on while still getting paid, so that's great. They're an agency. They do dealership, the whole package. So CRM, DMS, calls, texting, all of that. And they use a lot of different technologies. If you guys are ever interested, be my guest, look at them. Very fun place. And there's me if you want to connect. I'll post this at the end too, and a picture of me back in when I was a kid. Still had my hair, so you know, it's a good picture. It's probably not going to get changed. So first thing first, how did I find this problem? I want to tell you, because I came back to this industry, I was very confused. Because a couple of things. This is a new company. I was a teacher, new language, Java. Just been doing it for like 3 years. I think I'm pretty good. And years of catching up from architectures of microservices and all these other fancy technologies, whatnot. So while looking at this problem, I don't understand what's going on when I'm doing a simple query, a simple request. It's taking so long. Again, I'm asking that question, why is it so slow? Is it me the problem? I did anything I could think of, looked at the query. I did an explain plan on the query where the SQL tells you where it's slow, where it's not. And everything resulted in this is instant. But when I did a normal request to my service, it's always coming back very slow. So this question just kept on tackling me or bugging me. And when I started at the company, AI wasn't that much around. We weren't allowed to use it. And even now, if you can't pose the correct question to your AI, it's still going to give you some garbage answer or some normal answer that you would get anywhere. So I had a problem because I was using Google and Stack Overflow, but the problem was I didn't know what question to ask or what to look for, right? So again, I know it's slow, but it could be 1,000 different things when it's slow, right? So eventually my company, at the moment I was there, they started integrating observability. In our case, they started putting it all in Datadog. It's a bit expensive, but what it allowed me to have is tracing. So now I could see the flow of my request. I could see where the issues lies. And this is really the solution to be able to see it. Not solving it, but at least now I could see what's going on and what's the problem, right? I'm going to talk about this, and sometimes tracing, I'm talking about Datadog, but it doesn't have to be Datadog. I even have a local tracing tool for you. Not much setup, but you could still do it. So we'll get there. So with the tracing, I was able to find this. So what did I give? So this is a screenshot of Datadog. This is the span, and it's a part of the span. So in this case, you could see a database request that's going in. So for that one request, we see all of these requests going to the database, which is very weird. It was a simple request. So this is a span list. There's other stuff, calling other service. I just took this part for now. So this was my first hint. What I mean by this is that one query that was expecting to do to the database and get back my answer was coming out as 3,671 queries to the database. And you got to remember that your ORM and Hibernate and whatever tool you're using, they're going to try and not flood the database. So a lot of stuff they do is they do batches, and that means for 20 requests I'm going to send to the database, there's a lot of network going and coming back. So I can't send 3,000 in one shot. It will send 20, 30. That's usually the number they go at. So again, coming back to this, my one query turned out to be 3,671. Yeesh. Now I see something, there's a problem. And secondly, my query is not what I said. I had some where clause, X, Y, Z equals whatever, doesn't matter. But now I see a lot of these queries where it says ID equals question mark, the value it being. And it's not one, but like 200 for each one of them, right? So this is my hints. It's starting to tell me this is something related to N+1. Yet I didn't know what N+1 was, but these are telling me what to look for, right? Now the last part that's interesting, remember I said this query should be very fast. But all of these queries together now came down to 2 seconds. This is bad, right? If I look at those queries individually, each one of them, you'll notice the average is going to be nanoseconds or microseconds, very fast. So when I look at the database, everything looks superb. When I look at anything else, or like, let's say I take one of these queries and I put in an explain plan, very fast, very good. There's indexes, everything's okay. But when you add all of this up together, it starts slowing down, right? When you start making 10,000 queries, it starts slowing down. This is the problem of N+1. So let me go back here. So I'm just going to sidestep here. Knowing what tool correctly to use is a key point whenever you're developing, right? And when we started having this Datadog, they had it as a flame graph. And flame graph, like I see there's something weird here, but it's very hard to understand what's going on. So sometimes you have to utilize the correct tool to get the answer you need. This is a waterfall. So eventually they also had waterfall and eventually a span list. The waterfall is nicer because it groups them together, and now I could see the flow of my code. So somewhere along this code, I noticed there's like a mapping happening. And then when that mapping is happening, it starts calling multiple times, like 8,000 times the database for some queries. So this becomes interesting because now I could figure out exactly when this is happening, right? So utilizing the correct tool, the correct place, great. So normally we do a CRUD type of request, a REST normal simple thing, is we do a request, we go to the DAO query where we wrote our SQL, and that one's going to talk to the database, and the database is going to give us an answer, and we give that back as a response for our request. However, it's a bit more complex than that. By that, I mean the DAO is going to get the data back but we utilize these types of entities, like a class that specifies this is that table, so a row of that table, how it looks like. And when we do this, what I notice, again, I mentioned it previously, is there's a mapper that maps that entity to a DTO so that we send back with as a response, right? This is normally what happens. But for whatever reason, our DTOs are pretty big. So that one entity is not the only thing inside my DTO. So for example, let's say I have a lead. Inside that lead, that's one entity, but there's also the contact that's associated to that entity. There's also the cars that's being sold associated to that entity. So actually, I'm not mapping just that one entity, just the parts I need. I'm mapping a bunch of different entities before sending it. And you might have noticed is we always use kind of that same DTO for all requests. So we overload them with a lot of information. And this happens, I'm going to come back to this, but what usually happens is multiple entities are sent back with each one DTO. And this is a problem in itself. We're going to talk about this a few times, so just remember this part. We'll come back. So that's our N+1 issue. We have an entity. Well, it's an association level issue. We have that one entity. And now when it's associated to something else, to a different entity, we have to do another request to get that one, and another request to get another one, and so forth, so on. And so just to explain the key, the N+1. So we do one query for the associations. So it would say, right, for this contact is connected to this many leads. First one is find me all the IDs of these leads connected to this contact. Okay. And then for each one of those, so that's the one query. For each one of those, we're going to do another get where I get this ID. This lead, this ID, bring it back. This lead, this ID, bring it back. So we're doing N+1 queries. That's where the name comes from. Let's see what it means. So I have an entity here. I called it first entity. And we have a connection. This is our ORM. I have a second connection here called second entity. And in this one, it's pretty simple. It's a one-to-one. So for each one of those entities, there's one other of second entity, right? But what would happen if this was one too many? So for that one first entity, I would have 10 other second entities, 10, 100, 500, 10,000, right? We could have many connections. And you could have different types of connections inside this entity. So we have second entity, we could have another connection to third entity, so forth, so on, right? So, yeah. So ORMs. ORMs are there to make our life easier. It does everything for us, right? It makes the dev not need to think about the database and how the connections are. So when I do a query, I could get back everything related to my contact without specifying, I also need the lead, I also need these other things. So it makes our life easier. But why is it doing this problem? Most likely an architecture decision. So for example, if we do a query to get back a role, let's say we're getting back the role of a user, and the users are connected, the role is connected to users. Well, if I say, for example, give me back all normal users, all default users, all clients, well, there's a potential chance that you might load every client that exists in your database, right? Because they're all in the same specific role, that association that you have. So what the database does, or sorry, what the ORM does, is to say, rather than loading everything for you, which could put a big pressure on your database, and your database is usually the point of impact. If your database goes down, everything goes down. We're going to do smaller requests. We're going to give it to you as you need it, right? We're going to do lazily. When you need it, I'll start doing a request to the database. You don't need to know about it, but I'll give you the information you need. And by doing this, your query becomes very small, but as you need information, it will load it for you from the database without you knowing. So the moment in your code you say, first entity get me the second entity or get me whatever associated entity, it will start loading that data at that moment, right? So it simplifies the developer's job. Now, the ORM has to guess what you need, right? So this is why it does lazy. It doesn't always know you need that right away. So the moment you hit, let's say, that mapper, it's the moment it starts doing all these calls to get back that information for you. So it gives you what you need. And like I said, it fights against doing excessive queries, big queries that could crash your database, could slow it down. Your database CPU could be used. It could be whatever you want to call it. But the problem by doing this, it also hides it. So it hides it underneath these very quick, very fast queries that could have been one big one, could have been a small one. You won't know, but it does many smaller queries. So when we're looking at those, sorry, when I look at the database and I look at the queries that's done to the database, everything's nanoseconds. But when I do a request to my service, it's excessively long. It's 3 seconds, 20 seconds, 30 seconds. So this is an issue that comes with this lazy loading that happens. So as soon as we retrieve it, we map it. That's what we talked about. Now, lazy loading didn't really matter because as soon as we got it, we did the map, it retrieved everything. Now it's just doing a lot of queries. And this happens a lot with CRUD, with RESTful applications. Honestly, I see it a lot of places in my team and the other teams. And it's basically a DTO death, okay? So lazy loading is actually the problem that we have here. Okay. Now, before we go to solutions, I just want to tell you a bit more about my constraints. Because we saw the problem, we know there's a solution that exists. We could do a Google search, N+1. You even saw from the early LinkedIn post, one of them did an eager post. There's a lot of solutions. But there's always pros and cons, and we're going to talk about those. But first, my constraints. So the first thing I have, the issue where my issue is in monoliths. So coming ahead and saying I'm going to eager load everything is not a solution for me because there's too many places, too much time. Sometimes they reuse a DAO, multiple different services. Some of them need them, some of them don't. Eager could potentially grab more information than I need. There's a few other problems, we're going to talk about it, but I have huge monoliths, millions of lines of code, 10,000s of classes, etc. I have very old systems, Java 7, 8 with Hibernate 4. One of my confusions was a few of my teammates were always saying, let's go and split that monolith into microservices. Let's bring it to the newest Java 21. But even then, that's a lot of work and money involved. Your stakeholders might not say yes to it, etc. It's a good solution, but it doesn't mean you're going to fix the problem as well because you don't know what the problem is. And it's not easy to divide it and not easy to upgrade it. Again, I just talked about that. So let's talk about solutions. The first one is go ahead and on top of those entities, change it from lazy to eager. So I don't want to wait anymore. As soon as I do a request for this entity, go and grab every other thing that's associated to it. That could also be a problem because, well, you're retrieving everything. Sometimes you just need a small thing, but now you're retrieving everything every time. Sometimes, again, we're retrieving the roles, but now we're also retrieving all the associations, which could be the users. I could bring in 10,000 users, 100,000 users. We get the same problem, right? So loading too much, sometimes even more than my DTO. The mapper sometimes maps things. It might get a bit more than it needs, but it never goes till the end, right? Because usually when they retrieve everything from the database, the endpoint times out because we went over 30 seconds. We see some spikes, we see some problems. So you cannot avoid the joins. Even if you wanted to, it would load everything. So sometimes I just need a small part. So a few examples. Already, many-to-one and one-to-one does eager loading. Why? Because those are like one field. It's not a collection. It needs to tell the developer, this is null or not. So right away, it does it so the field is nullable or not. Collections, on the other hand, is always an empty list, and then it starts populating it as you require. So when we do something to one, it loads a single row, very low impact, doesn't matter. But when we start doing too many, so one too many or many too many, which is insane, now the collection size is unknown. Again, you could potentially retrieve everything inside your database, so it's a high risk. So those, by default, it does a lazy loading. Again, because you don't want to retrieve everything, you would crash everything, right? So the first answer is, and you're going to see this a lot, it's inside your queries, do a join fetch. A join fetch is not an SQL query. So the fetch part is not. What it is, it's for your ORM to say, I want to eagerly load this collection that comes with my query. So rather than doing, let's say, 1 and 10 others to get that collection, it will just do 1 and grab everything in one shot. Okay, great. Pretty good idea, but come back to our constraints. My constraints was, I don't have that time to go and change all of these queries that I have. Remember, I have a monolith. And sometimes those queries are used multiple places. So some guys like, I have a query here. This looks pretty much what I need. I'm going to reuse this method. So there's now 2 business code that's using the same DAO query. And I could potentially make both of them eager, but maybe one of them just needs part of the code. So it's too much to change. And I'm kind of a bit lazy. So we also bring back a little bit of complexity because join fetch is not that straightforward. You could do it with one join, but a second join inside would not do this. So now they would have to learn fetch and a bit of SQL configurations, etc., which kind of defeats the purpose of the ORM. We're kind of forget it, make it into a code, so the dev doesn't need to know about SQL or how it talks to each other. Okay. But again, join fetch is a great solution. Don't get me wrong. It's just, for my monolith, it's not the best. So what else is there? There's this thing called the batch size, and usually called a hack. So we talked about the database and how we communicate to it. We send it in batches, those queries. So we load 20 queries and we send it to it, and the database responds. So like this, we don't. Our connections are not too long. Our request to the database from our service is very fast. What you could do is actually say, I'm going to increase that size. And initially, I started doing that on an entity. There's like annotations. And doing that I was starting to see some progress. So now one of my queries was coming back much faster. Still not as fast. And I had a lot of different entities. I didn't want to go around and putting this annotation on anything. You could put it on the joins. You could put it on an entity. It was a good solution, but it's not the one I want. I want to kind of do it for the whole service. So changing the configuration, I found for Hibernate, you could change the default batch fetch size. And now this applies to all my entities, everything inside that one monolith. Okay, so great. So what does it actually, well, okay. So rather than grabbing one at a time now, it would grab multiple. So remember one of the queries I saw in the span where I was seeing 200 times this table, grab me where the ID equals this. Now it would say, grab me again from the same table, but grab me this ID and this ID and this ID and this ID. And this was becoming very interesting. So now less requests, well, more in one request than normal. Oops. So I started increasing it 20 times, 50 times, the number, I just increased it. And it's getting there. My speeds were starting to come to where I needed to be. I had some endpoints that were timing out because they were passing the 30 seconds. Now I was getting them to work. So I increased it. So I didn't need to change the monolith because I'm lazy. And what are the drawbacks? So I needed to increase this a lot more to see great speeds. I couldn't just do 20 and it was good. You saw I had 6,000 in that example. There was some that had 20,000, 50,000, etc. So I needed to increase those things, which created a problem. It created more prepared statements. Prepared statements is a query that it's prepared for you, so for security reasons and speed, where you could just plug in values and send it to the database. It was creating more of them, because initially it was just a prepared statement that said ID equals question mark. But now the prepared statement was ID equals question mark or ID equals question mark, and kept on going. So the higher I made that number, the longer that prepared statement was, right? So now, let's say I put it to 5, there was 5 of those fields inside the where clause. But the problem with that was it also needed a prepared statement if there was only 4 of them. You also needed a prepared statement if it was 3 of them. Prepared statement if there was 2 of them, prepared statement if there was 1. And I don't know if you see it, I went much higher than 5. I went to 50. So it has to create for every query 50 different prepared statements. Where does it put all those prepared statements? Inside the memory. So what happened is I got out of memory exceptions. My service didn't have enough memory space, or there wasn't allocated enough memory space to have all these variations of prepared statements-ish. That was the biggest drawback. So memory increased with prepared statements. So what can I do for that? Actually, 1 second, did I go back? Sorry, I have 2 of the same slice. So what can I do with that is, what if, because already my service is very slow, what if I'll save the memory, but I'll use a little bit of the CPU? Because already the CPU was going crazy because these long-running, I forgot the word, long-running request was very bad for my service, right? And by the way, there's a lot of issues with long-running requests. Well, as soon as it runs, sometimes the user gets tired and does another request. So now I got multiple parallel requests of this very bad whatever is going on. And then as more requests comes in and I'm not fast enough to send back a response, eventually all my threads are busy. And at some point when all my threads are busy, I don't respond to any request. So new requests are denied to start. So what I said is, what if those prepared statements, rather than prepping them early on, we do it dynamically? So as you need them, I'm going to prep them, create them, the size you need it, and I'll give it to you. So what happens now is my memory is much more stable. You don't see the out of memory here, but this was how it was normally with the prepared statements. And this is how it became. So now, as you need them, it will create them, right? It will create them, put them in the memory, and eventually the garbage collector will just come and erase it, because now it's not used. You need it again, I'll create all of those prepared statements that you need on the fly, use a bit of the CPU, use a bit of the memory, of course, and as soon as we're done, garbage collector come, clean it up. Great. Now, interesting enough, I'm back to being stable. I'm not hitting the out of memory. And it's actually sometimes when the service is not being used, the memory is very low. So it could work on other things. Not bad. So what happens is the CPU, so this is the dynamic batch fetch style. This is what you put. So what happens to the CPU? So again, if I didn't mention it before, this is in the middle here is where the new system is in place. Before that, this is a nightly run that was happening on this specific service, this monolith we had. And every night from 2 a.m., there had a lot of nightly jobs that was going on. And you could see from the night where it starts at 2 a.m., it ends around very far in the day. It takes like 4 or 5 hours. Actually, that could potentially be the reason why they moved these tasks to the night, because it was too long and we can't do this during the day because we won't accept new requests. Our clients would be pissed. We'll get new support tickets. My boss would be on my neck, right? So they most likely moved this at the night because of this issue. But as soon as we changed this to, as soon as we found out this N+1 and we made it dynamic, now we got these little spikes. Honestly, this is the CPU working very hard, but normally the CPU has to wait for a lot of database requests, so I don't think it's a fault of my dynamic thing. But now it works very fast, very hard, just for a few seconds, cleans up the memory right after, and you could see it goes back to normal. And what we get is now this 4, 5, 6 hours long running tasks are becoming very quick. Now our CPU, we get some spikes. This is the initial one. You could probably ignore that, but it comes back to approximately pretty good using 2 cores, while before it was using 1.5 for long duration. So this was kind of a drawback that I was okay with. So dynamically create those prepared statements, a little bit of action, which is much shorter than a long running one, and garbage collector coming to clean up whatever I left, which was very nice. Now, database, this is my one database. In our company, we had the main database, and we had a replica. So the same long running, again, I deployed around here, the long running nightly jobs, we could see it brought the CPU very high. So the database was struggling, not struggling per request, but struggling by the amount of requests coming in. So every request is very small, but you're sending me thousands and thousands of requests. And as soon as we changed, well, now my database, which is my biggest point of impact, all my other service depends on it, is much nicer. It's cleaner. My infrastructure guy was very happy with this because he was complaining about this problem and no one knew what the solution was. So, and putting it side by side, my service is at the top, my database is at the bottom. We could, again, see the moment we started changing this, both of them kind of let go a bit of the CPU, which is very good. Cool. So what is the real solution? Because my thing is still a hack. I did that because of my constraints. I had a monolith. I had a lot of stuff to change. I don't want to figure out each business case, each requirements is too much. So what's the real solution? And the joint fetch is okay, but the real solution is when you're doing a selection, create a DTO for the database. It's very rare that you need every field inside an entity. And what some of the questions I got by saying this to my colleagues is like, it's a lot of work. It's a lot of classes. It's a lot of issues. I'm like, really? You're not constrained. Like, let's say if you were doing mobile, there's a limit to how many classes you could create. But inside your service that you make a server, you don't have this limitation. So create as many DTOs as you need. Reuse them if you want to, but it doesn't matter. Create them. Honestly, I see more people bring in libraries, which brings in thousands of class, which is a lot more issues than just go ahead and create a few more DTOs. You could copy paste some. Even now with the AI, you could create those DTOs very quickly. Especially if you're in the newer Javas, you could specify, it creates all the getters, the setters, all that stuff. It's great. And the only time you should use an entity is the moment you want to create, update, delete, because there might be some constraints on those things. What constraints? It depends. There's a lot of things that could happen. But when you utilize entity, this is for sure you're trying to do a change on the database, and whatever rules on those entities, you want to make sure it applies. So in this case, this is the only time I would tell you, utilize join fetch as required. Otherwise, you don't really need join fetch for a select because you know exactly what you need, and that query will give you back that data. Very much only when you're utilizing the entity, the ORM, that you get this N+1 issue. Now, last thing, I wanted to do a demo about this, but I was messing around with my computer and I broke some of my stuff, so I couldn't get this tool running, which is very unfortunate because it's a very nice free tool for developers. And what it does, you install it on your computer, and it creates you some Docker image on your computer, utilizing Docker Desktop, utilizing whatever tool you have, Podman, etc., Kolima. Now, what it does with this tool, it's very nice. It gives you tracing, but locally. And even better, you have to do no setup. So as soon as you got this running, it would automatically inject itself the moment you press debug and IntelliJ. So at the first line of your service starting, your debugger or your runner, you're going to see debug injected inside your thing. Great. Now your service, you let it start. When it started, do a few requests. It will capture, create you it'll create you a waterfall, and you're going to see all those requests. It even is going to tell you if there is a potential N+1 because it sees the repetition. Very great tool. I'm not associated to them, but top notch. And that's it for me. Thank you.